So I needed to work out exactly what features I wanted to use to fill the gap. So commonly with how you work with Entity Framework, you have a DB context and DB sets. And I really like this interface with the database, so I knew I wanted to have this. And this thing's pretty easy to do. One of the things that DB sets give you is change set support. So with change sets, we can actually queue up a variety of changes and then save it all at once. With the MongoDB driver currently, you would either have to queue up all of your update 1, update many models, and then put in a bulk write call. But this is what I'd prefer. Prefer it to kind of handle that all the way itself. Just add my objects to a collection. When I call save changes, it saves. I wanted data annotations. Admittedly, this isn't as useful as it might seem because, as you might notice there, we have table. We don't refer to it as table in MongoDB. We refer to it as a collection. We don't refer to it as column. We refer to them as properties. But nonetheless, I wanted this because it was an Entity Framework-like experience. Change tracking. This was an important one for me. I wanted to be able to just track the actual change I've made and push that to the database rather than call a replace one document in the MongoDB driver. So I had kind of a dilemma here. Would I build the MongoDB driver into Entity Framework, or would I try and make something act like Entity Framework? There's pros and cons to both, where the MongoDB driver has its own mapping system, but so does Entity Framework. I don't want to have two conflicting mapping systems, and one way or another, I would have to actually pass the data between them. So to try and avoid doing that, I opted for a different solution. I opted to just imitate Entity Framework, because for those features I listed before, the DB context, the change tracking, these aren't the hardest things to implement. I mean, it's a lot of work, but you know, it's doable. So I spent a good portion of 2017 actually working on this in between my day job to try and build this into an actual tangible product or library. So I added DB context and DB set. I had change set support, the data annotation attributes. I had change tracking, and I could do diff updates. So I could actually see what particular properties, however nested in your structure, and just push those up to MongoDB. Now in 2022, though, I've gone quite a bit further. So I have some other really interesting features along the lines of index attributes. In Entity Framework, you can just specify an index attribute and have that apply your index to your table. So I wanted the same thing in MongoDB. But MongoDB's got some more interesting and complex indexing support. So that was a challenge, but I'll go through that bit more detail later. Entity buckets. The idea of storing many smaller documents within a larger document. I had runtime type discovery. So you may be aware when you actually have derived types in MongoDB that you have to specify the beSONKnown type attribute. I didn't like that. I would rather it just know and work it out. So with a bunch of time and effort trying to work out how I would do that, I implemented that in MongoFramework. I had MiniProfiler integration. So this is a profiling tool made by some folks from Stack Overflow. And it can profile your page as well as any other queries or anything else. I knew I wanted that integration as well. And then I've also actually had a few community-built extensions. Someone built a ASP.NET Core Identities extension in MongoFramework, as well as multi-tenancy support. So now I want to go to working smarter with MongoDB via MongoFramework. So these examples should all feel very familiar to you from using Entity Framework, because that was the point. It's meant to be as close to Entity Framework as I reasonably could. So setting up a model. That's a basic class in C#. You have your ID property, which here is just a string. That will automatically be mapped to the ID of your collection. And then we just have the various other properties that we want. And the collection name will be the class name. So quite straightforward. For the DB context and DB set, I didn't want a name collision, so I decided on MongoDB context and MongoDB set. But again, it's very similar to how it would be for Entity Framework. To use this, you can do dependency injection way, and while there's definitely a lot of people that get either pro or con dependency injection, you can do it, and through specifying a MongoDB connection, which is a light wrapper around the MongoDB client, it can power various other features through MongoFramework, some of them which I'll cover a bit later. And then it's just as simple as then adding your context as a transient service to your service collection. But because it's that simple, you can also just do it without dependency injection. There's no reason to prefer necessarily one or the other. MongoFramework doesn't care. As long as you correctly dispose of your context like you would in Entity Framework, everything will work out fine. To query the data, again, looks very similar to Entity Framework. And you'll see this as a theme. It's the point that you've just got your link query, same type of stuff. That's primarily backed by the MongoDB driver with a few little interesting bits here and there that I've had to implement myself. But we have support for even as no tracking, the same way that Entity Framework works as well. So again, just the theme of wanting to be familiar while also being its own thing, knowing that there are certain features of MongoDB that you couldn't replicate as easily within Entity Framework. So designing it from the ground up was the better solution. We can add, update, and remove entities all the same. So taking advantage of our change set support and our change tracking, we can, with just a few lines, add a movie in this example. We can update an existing movie genre by just adding to its list. We can remove a range of different movies by a particular genre. And when we call save changes, all of those occur at once. We don't have any weirdness of some occurring and some not occurring. These are all put together, sent as a bulk write command through MongoDB. So now I want to talk about getting smarter with indexing with MongoDB. So I said earlier that MongoDB's got some interesting functionality with indexes because, well, there are multiple types of indexes and some interesting ways you can work with it. I mean, in the most simple index, it is just an index attribute with your sort order. That will get you there majority of the time. But you can go a bit further. You can have a named index. This is how you go about having a compound index across multiple fields. But it gets even more interesting because you can go to a nested compound index where you actually have a nested type and the root type share an index between each other. And MongoFramework will work out this structure, find the names that match, and correctly create the index in MongoDB. So now for one of the more interesting indexes in MongoDB is the text index. And in MongoFramework, it's as simple as specifying the index type as text. You need to call search text because one of the limitations with MongoDB itself is the aggregation pipeline that you need to specify text as the first item in the aggregation pipeline. Also does geospatial indexing. So when looking at this, I was deciding between whether I would support, because I believe there's two types of geospatial indexes. There's Geo 2D Sphere, and then there's, I think, just Geo 2D. And the idea here, though, was after researching, I'm like, OK, Geo 2D Sphere is the one I wanted, and I support both the geo-near and geo-intersecting queries. So now that we've seen how we can just use it in the more normal context, we can see how we've applied indexing. Let's have a look at how we can take advantage of entity buckets, a smarter way to actually work with our data. So what is an entity bucket? I kind of said it briefly before, but basically we have a bucket, which is just a normal document, but it contains many subdocuments. So we can have like 100 subdocuments to one document. And this is a way that we can take advantage of time series data. And in terms of like bucketing that, taking pressure off of indexes for MongoDB. How we specify this, though, is via two different types. So we have our bucket group, which acts kind of like our meta field for it. So in this case, we have a movie ID. And then we have our detail type. This is the subdocument that we're going to be storing. So in this case, we have a rating and a date. The date's important because, as a time series way of storing data, well, we're going to need a date property somewhere. Behind the scenes, this is actually what MongoFramework is doing. It combines those together in a more detailed structure, tracks how many items are per bucket that we have, and it takes all of the kind of mental work out of handling this bucketed data. So you don't need to worry that, oh, I have 200 items here and 50 items there. MongoFramework will make it seem to you like there's 250 items, but will make it easier for MongoDB to actually handle. To specify an entity bucket in MongoFramework, we just add an attribute for bucket set options. We specify a bucket size and our entity time property. We also just need to specify it's a MongoDB bucket set versus a MongoDB set with our group and our detail generic parameters. And working with this, though, is more or less as simple as working with any other DB set. We just set our group at the beginning, and we can specify as many subdocuments after we want. The subdocuments, that can be far greater than the actual number any bucket can hold. MongoFramework will write the query enough that MongoDB will correctly insert only up to the maximum number of items per bucket, and then go on to the next bucket for you. Then reading this data, it's also as simple as just calling with group to actually get that group of data that we want, our buckets, and then just filter out the data that we actually want within there. So we might be thinking, especially if you saw yesterday's talk about time series collections, is, well, what about MongoDB time series collections? Because clearly they sound very similar to what I've just described. And yes, they are very similar. It's probably, there's a great overlap between the features, but I still think that there might be a room where one might be better than the other in certain scenarios, but it's something I need to investigate further. So now I want to get on to talking about profiling in MongoDB, and more specifically, profiling your queries within your page, because as you probably already know, that we can already get detailed profiling information from MongoDB. We've got the explain path, and there's various other tools that can tell us how our queries are performing. But if we want to see how it's performing within our page, that's where we need to rely on other tools. So using MiniProfiler, this is, again, a tool made by some awesome folks from Stack Overflow. We can actually have a look at how the profiling information of our actions and views within a page, as well as any particular external calls that we might make. So in this example, we have SQL readers and HTTP being broken down into what their contributions are of loading the page. And this UI all comes from MiniProfiler. And then when you dig into any of those details, it will actually explain to you the full detail of the queries, of the HTTP calls, and of the readers calls, just so that then you know what's actually going on with the profiling. I wanted this with MongoDB because, well, if I'm going to all the effort of making MongoFramework, why don't I have this too? So I did. I added, through MongoFramework's ability of wrapping how the driver works, I can inject things at the right point to actually profile the data and pass it through to MiniProfiler. One of the things I really like here is that we can differentiate between the first result and the actual total time. That's useful to know how much is the query itself, the processing on MongoDB's end, versus how much is actually sending through the data back to the user. Configuring it is relatively straightforward. It's not the most elegant solution. That's probably the only other thing I should mention. Obviously, these service collection extensions are not as nice as the entity framework ones. That's something I'm working on. But here, we just basically specify our MongoDB connection with our Mongo URI, and we just specify the diagnostic listener. So in this case, we have the MiniProfiler diagnostic listener. This will then hook into various internal bits of MongoFramework and pipe through all of the profiling information. So I said at the beginning about working smarter, not harder. And what you might probably gather from all this is it's not necessarily smarter for me to write all of this stuff. It was quite a bit harder for me just to write all of this code. There's probably a better solution, but at the same time, it worked. It worked for me. And I've had even a few clients and stuff come up to me and got work from it. So this has actually been quite successful for me to build it. And I wouldn't be here today if it wasn't for writing MongoFramework. The idea that developers can use something that's now more familiar to them than just using the driver directly is something that I see as a net positive to both the .NET ecosystem and the MongoDB ecosystem. So what's next for MongoFramework? There's a lot of features I want. Some of them are definitely harder than others. One of the longest term features that I've wanted to add is GridFS. So for those that don't know, more or less, you can get more than 16 megabytes into a document. That's, or at least how I would phrase it. James Kovacs might phrase it a bit differently. Transaction support. Now, this one's hard because the way that MongoFramework works is that it never actually goes out of its way to create a collection. When you push data through to MongoDB, it creates a collection automatically. So transaction support is tied to when a collection is made. And I believe it was MongoDB 4, it still had issues where you couldn't create a collection within a transaction, and you couldn't create an index within a transaction. So that's been one of the things holding me back, because MongoFramework doesn't actually look at which version of MongoDB you're using. Then, like I mentioned before, we got the MongoDB 5 time series collections. I'd want to get better support for that. Fluent model builder, that's kind of probably one of the other big pieces that's missing from this entity framework experience, because not everyone likes specifying attributes on their models, and some models, well, you just can't add attributes to because they're not your types, they're someone else's types. So I want to add support for that. Service collection improvements, like I mentioned before, they're not necessarily great having to specify your own add transient, but they do get the job done. But finally, I would really, really like to integrate with MongoDB's C# analyzer. And the reason it doesn't is because of some of those features that I've actually got that wrap around the driver. Because the driver exposes a iMongo queryable, and MongoFramework just exposes an iQueryable. So the project is up on GitHub. You can find it there, give it a star, do a pull request if you want. That'd really be helpful. I've got my own website where I've got blogs about anything .NET related or just programming in general. And then you can find me on Twitter under Mr. Turner J. And that's all. Here to take any questions, if there are any. And yeah, thanks for listening to me ramble on about my open source library. Yep.
In your slides, it appears that you're using the Mongo, you're creating a Mongo client every connection?
No, so the MongoDB connection, because yeah, in the slides I do have an add transient that does add the, it would create a MongoDB connection, which internally would create a MongoDB client. My understanding though of still how the actual driver works is that it is still pooling the connections and stuff at the back end. So it shouldn't be interfering with that process with the driver. Yep.
You mentioned extensions that are being written. It looks like EF, but it's not EF.
Yep.
Is there ever an issue with people trying to tie into actual EF extensions?
I haven't had that be an issue yet. It's kind of an odd situation where, yeah, I might end up with some problems potentially in the future where, because of only making it look like EF, if someone wants, oh, yeah, this specific thing works for EF, but now this doesn't work for this. But that's kind of just one of the trade-offs I had to make with trying to make this both light and then not have conflicts between how Entity Framework does stuff and how the MongoDB driver does stuff. I'd rather try and be more around what the driver itself does. Yep.
For unit testing, do you have interfaces on that so we can mock things out?
Yeah, so for the connection and context, there's interfaces for those. For the multi-tenancy support, because some of that is built into the actual core Mongo framework, you can unit test all that. I've got unit tests that if you need to base anything off of in the actual GitHub project. Yep. No, Not really. So because for the most part, it doesn't actually do anything overly more per query or per write than what the driver is doing, you're not going to really notice much. I do handle some mapping stuff myself through MongoFramework that allows me to do a bit more, which on first run will take up, allocate a bit more memory. But on the per query basis, a lot of it is just being forwarded through to the driver. The what? Oh, yes. That was probably the other important thing that I missed, is indexes, because of how they work and because of how I've got everything piped through, indexes are only created when you call save changes, because at no other point do I actually have a potential async flow that I can actually hook into. So you could essentially call something in your startup onto like a blank DB context to call save changes if you want your indexes to apply at startup of your code. Otherwise, they'll apply basically the first round they get if they're different to anything that's already in MongoDB. Oh, yeah, yeah. So it's in the lifetime of your application, I'll be able to check whether the index has already been created or not. So I'm not constantly sending up, because yeah, that would be a painful experience. I caught that one out pretty fast. Yep.
How do you handle schema evolution? Because obviously that's one of the main selling points of something like Mongo. This sounds like you're tying it back to a single schema, which reintroduces evolution problems.
Yeah, so one of the things that I've found is that there isn't necessarily an overly straight path forward in terms of data migration through MongoDB, even without MongoFramework. But in terms of, I guess, broadly speaking, of actually just like transforming your data from one thing to another, there's probably nothing that MongoFramework is holding you back from doing anything you currently can do with Driver itself. So anything you can do with Driver itself in terms of being able to move from your schema of one particular thing to another, you can do with this.
So I guess a corollary question then
Yep.
would be how, like through the process of developing this, have you come up with any like tips and tricks for something like a very strictly typed system like C# on top of Mongo versus like a Python or a Java?
Somewhat. So like one of the things I've been kind of experimenting with is a more, in the same way that entity framework typically, and with like SQL, you would generate a migration which then says, okay, these are the actual changes between it, and I'm going to save that somewhere, and then you can perform all of those changes. I've been kind of contemplating looking at that as a way to move from the strictness of the C# objects to the fluidness of the BSON structure in MongoDB. In terms of what you could do right now is more of you can map particular columns. So if you added a new property to your C# object, you could map that column to an existing set of data using the column attribute, or whatever the native one is actually for the driver, because they're fairly similar. And yeah, so like adding new data and then pushing it, that's kind of a still more manual process of like transforming the data. Removing the data is probably a bit more complex, but this supports the extra elements process that the MongoDB driver exposes. So that should all work still. So it just exposes a string dictionary of objects. Any other questions?
Piggyback off of that, if there are no other questions, is that we have design habits in MongoDB as well. And there is a schema versioning design pattern. I believe Daniel Kupal covered it in his talk. That hasn't happened yet. So that's something that you're interested in, that's fine.
No, that definitely is. Whenever you build frameworks like these, it always seems to me you target, whatever you're doing in that moment.
Yeah.
You don't think, well, okay, now I have this string, I have to turn it into an array of strings. How is that going to change my
Yeah.
models and my framework and how is all that?
So I mean, at the moment, it's definitely a matter of probably adding a secondary property and then kind of manually controlling your reads and writes to that. It would be nice for a more automatic process. And that's definitely doable. That's something where MongoFramework might be able to help out and like build upon what the driver actually has to have some type of converter that you specify that can just automatically handle that type of conversion for you. I mean, on some level, that's what you can do with the BSON serialization of going, okay, this is one of the properties I want now to be over here. But then that's complex because you're now doing the full BSON serialization part rather than just going, okay, this is now this. Yeah? hopefully you all enjoyed that.